Hey, Rouse. Let's take a look at lesson 3.7. For example 3b, we were asked to solve an exponential equation. And in the printed lesson, I mentioned that we ended up using trial and error. The reason why we had to use trial and error is that if we try solving this using our skills from lesson 3.3, I could undo the multiplication by 4. Dividing both sides by 4 gives me 25 equals 1.12 to the exponent t divided by 3. But then here's the problem, is that my strategy for solving exponential equations at this course level is to try to write both sides as a single power of a common base. And I'm finding it difficult to write 25 as a power of 1.12 to the exponent t divided by 3. The printed lesson alluded to a method in advanced functions. I'm not going to show you that because we don't need to know that, and it can cause problems. And then I mentioned using technology. So that's what I want to do now. Let's just switch what we are presenting here and open up Desmos. Now we've got two options here. Into Desmos, we can type in the original function. I'll just put, what was this? This was, well, let me write out the equation. I think it was v equals 4 times 1.12 to the exponent t divided by 3. And notice how Desmos assumes that those are my dependent and independent variables. If you can't remember the example, we should be able to look at this function and figure out what's going on here. This is something starting with v. I'm going to assume value that had an initial value of maybe $4, maybe $4,000, $400. I think it was a card that had an initial value of $4. This looks like a growth rate of 12% because I keep the 100% that I begin with and then I go up by 12%. And that right there is my length of a growth period. If I substitute in t here, I can make this a function. Shouldn't, there we go. Shouldn't cause any issues. If I substitute in v of t, that means that I'm going to be growing by 12% only once. So here's our curve. I can zoom out. I could change the scale myself. The question asked me, let's figure out when this card will have a value of $100. So I can just type in new, curve y equals 100. And Desmos does a pretty good job of just finding a point of intersection if you just click on one of these functions. There it is right there. So I will say that it takes about, or it would take about 85.209 years. That's a little bit off from my estimate, and I think that's because of all the rounding off that I did in the lesson. Either that or there was a mistake in one of these approaches. But so this is not something you're going to be doing on a quiz or on a test. You should only be able to solve exponential functions where you can write both sides as a single power of a common base. But like what happened in the lesson, you should be able to solve for other unknowns.